we have this set of all problems which could be verified in polynomial time. So this set even contains p algorithms, right? Now what I'll do is I'll try to find out one problem to which all the other problems, every problem in NP could be reduced to that problem in polynomial time. Let us say I have a problem P, some problem P1, okay? Using the problem, if I use the name P, don't get confused that it is a polynomial time algorithm. Let me use some other name, say A. Let us say I have a problem A, and now I am able to, this problem is in such a way that I found out a new problem in such a way that every problem that is in NP could be converted to this problem in polynomial time. It is such a problem. Every problem in NP could be converted to this problem in polynomial time. Why do you think that such a problem is important to find out is because it makes many things easy. One thing it will make easy is, in order to prove that every problem in NP can be solved in polynomial time, you need to just prove that you could find a polynomial time algorithm to A. Therefore, instead of doing research on all these problems, you could take only one such problem and you can work on it. In case if you find out a polynomial time solution for that, you could declare that every problem in NP can be solved in polynomial, and so P equal to NP. Okay, so what is this? Again think about it. If every problem in NP could be converted to a problem A in polynomial time, then we can say that the problem A, if it could be solved in polynomial time, every problem here could be solved in polynomial time. Why? We already have the polynomial time conversion and now polynomial time solution. Therefore, we got the polynomial time solution for all these problems. So all of them becomes P. Now we have found out many such problems, right? And the name given to such a problem is NP hard. Okay, so what is NP hard problem is, I'm talking about NP hard problem. You could write about it. If every problem in NP can be polynomial time reducible or polynomial time reducible to a problem A, then A is called NP hard. Alright, so what does it mean? You understood this. The problem A is as hard as any problem in NP. Why? Because if you can solve this, it means that you are able to solve everyone. You see, it is like this. This is a classroom of all students, and now we have arm wrestling. Okay, and now there is a boy who has defeated everyone in the arm wrestling, right? Therefore, he is very strong or very hard. Now I'll take that boy, and if I defeat him in arm wrestling, then what can I say? I could defeat all of them in arm wrestling, right? Therefore, beating one such problem is enough to beat all these problems, right? So now what are the conclusions that you could come with? I mean, what is the significance of such a problem, or what are the implications of this is, what is the implication? You just come with that. I'm saying that if A is such a problem, then you could make a simple statement. If A, which is NP hard problem, if A could be solved in polynomial time, if you could solve a problem A in polynomial time, then what does it mean? Then every problem in NP is P, polynomial time solvable. Think about it. If you are able to give a solution to a problem, NP hard problem, in polynomial time, then every problem in NP could be solved in polynomial time. The reason is you can convert every problem to that A, in polynomial time and then solve that A, so that this answer to A will be the answer to this problem, right? Therefore we are able to solve all the problems in NP in polynomial time. Then what happens? Then every problem will go and sit in P. Therefore P will expand and it will take up the entire NP. Then in this case, if this happens, if a problem in NP hard problem is solved in polynomial time, then we can say that P equal to NP. But till now, no one did it. No one is ever able to find out a polynomial time solution to any NP hard problem. Got it? And now the next one is, one more notation is there, which is called NP complete. NP complete. NP complete is nothing but if this problem A so happens that it is also NP, which means if the solution to A can also be verified in polynomial time, then A is NP as well as NP hard. Okay, think about it. If this problem A happens to be present in this set itself, which means we have taken see, it is like this, we have taken a boy from the same class, and now in this classroom this boy from the same class is able to beat everyone else, right? Then what happened? That boy also belongs to NP class as well as that boy is NP hard. Therefore what can you say about it? He is NP complete, right? So if you can find a problem in the same set, which means if you can find some problem in the same set NP in such a way that every other problem could be converted to this problem, then what can you say about it? It is NP hard because it is as hard as any problem in NP as well as it is NP. Therefore it is NP complete. So NP complete means a problem is said to be NP complete if it is NP. NP means there should be a polynomial time verification algorithm and NP hard. Got it? So this is true, which means if a problem is in NP as well as it can be every problem can be converted to it, then we call that problem as NP complete. So maybe if you are wondering what is the relationship between P, NP, NP hard and NP complete, maybe I'll tell you what many scientists are actually believing as of now. So many researchers in this field, they believe that, see, we don't have any concrete proof saying that P equal to NP or P is not equal to NP. But then because of the lack of proof for these many years from 1970 to this year, we don't know anything about NP, right? Therefore researchers started believing that it must be some diagram like this. So what researchers believe as of now is, assume that this is NP, which means set of all problems whose solution can be verified in polynomial time. They believe that since we are not able to solve every NP problem in polynomial time, there must be really some problems which we may not be able to solve in polynomial time. Therefore they believe this. They believe that, you know, P is present in NP, P is inside NP. Which means there are some problems which can never be solved in polynomial time. That is what they believe, but they might be proven wrong in future. If someone comes up with a solution and solves every problem in polynomial time, then they might be proven wrong, and what happens? P become NP. But as of now many people believe this, right? And now according to our definition of NP hard problems will be set of all problems to which you can convert these problems. Therefore NP hard problems will be some set of problems to which all these problems can be converted. So this is NP hard. And now what is NP complete? A problem which is present in NP and a problem which is NP hard as well, then that is NP complete. Therefore this is NP complete. So this is what many people believes. This circle is NP, this circle is P, and this is NP hard, and this is NP complete, right? Now what is the importance of having such problems is, now if you want to test or if you want to do some research and if you want to find out whether P is equal to NP or P is not equal to NP, you need not solve every problem. You just take one problem which is known to be NP complete, and from that problem you prove that either you cannot solve it, okay, you prove that you can solve it in polynomial time, then everything is over, P equal to NP, right? Or you take one NP complete problem, Why? NP complete problem is already known to be present in NP, isn't it? And now you say that it can never be solved in polynomial time. Then you have found out at least one problem which is present in NP and which is not present in P. I am not talking about NP hard problems. See, now what is the significance of NP complete problem is, you do some research on this. If you are a researcher, if you are a PhD student, and if you are working on P equal to NP question, then what you should do is, you need not worry about all the problems. Take only one problem which is known to be NP complete, right? And then you try to give a polynomial time algorithm for this problem. If you are able to give a polynomial time algorithm for this problem, it means that you can solve a NP hard, it is NP hard as well, right? It means that you are able to solve a NP hard problem in polynomial time. Therefore, every problem in NP can be solved in polynomial time. So, if you are able to give a polynomial time algorithm to this, then you can say that P equal to NP, right? Or if you are able to give a proof that I cannot solve it in polynomial time and no one else could, which means if you can find out a proof saying that this problem can never be solved in polynomial time, give a proof. We all know that it is possible that many problems are not in P, but you should be able to give a formal proof, which is really, as of now, it seems like impossible, right? If you are able to come up with a proof saying that for one NP complete problem is not in P, then what happens? You have effectively found out a NP problem, which means some problem in this set which is not in P. Either you prove that at least there is one problem which is not in P, then you can say that P is not equal to NP. Got it? So simple words, in simple words, take an NPC problem, solve it in polynomial time, then P equal to NP. Take an NPC problem, say that it is not in P, prove that it is not in P, then P is not equal to NP. But till now, no one is able to do that, right? So we are able to find many NP complete problems so that people can work on them. They can work on all these problems, any problem that they like, but then they should come up with a proof. So let's just summarize what we have learned till now about P, NP and NP hard, NP complete. What is the significance of these problems is, now either you solve a NP hard problem or you solve a NP complete problem. If a NP hard or NP complete problem is solved in polynomial time. Polynomial time. So what does it mean? You are able to convert all the problems to one problem, and now you are able to solve that problem in polynomial time. Therefore, every problem in NP can be solved in polynomial time. Polynomial time. Then every problem in NP can be solved in polynomial time. Therefore, NP equal to P, right? Which means P will contain every problem now. Therefore, if any problem can be verified in polynomial time, then it could be solved in polynomial time, right? Now, it is important. Why am I taking either NP hard or NP complete is, actually NP hard, saying that NP hard is enough. If a problem is NP complete, definitely it is NP hard. I need not say these two terms. Why am I specifically saying it is, in exam, if they give you this or this, you might complain later that you didn't say this or this. That is why I am writing it. So either the question is, either if they say that NP hard problem is solved in polynomial time or NP complete problem is solved in polynomial time, both are same, right? In fact, writing this is actually writing this, but still I'm writing it. Okay, you could take these two and by heart them. Okay, and now second one is either an NP problem or an NP complete problem is proven to be not solvable in polynomial time. What does it mean? a problem which is NP, which means which is present in NP or NP complete, is not solvable in polynomial time. So we have this and we believe this as of now. This is NP and this is P. We believe this as of now, and now we are giving a proof that a problem NP means either it could be present here. See, you need not talk about P because they have already been proven to be polynomial. Now NP means it is present here, or it is already, all the other problems have been converted to this, right? So in this case, if you are able to find a problem and you are able to prove that it cannot be solved in polynomial time, then you are able to find out a problem which is not in P but in NP. Then what can you say? Then if this is the statement, then you can prove that P not equal to NP, right? So no one is able to do either this or this. Therefore P is equal to NP or not, that is still open. See, coming to the second statement, I could have just said an NP problem because it is enough. NP problem or NP complete problem, it is just enough to say that NP is a stronger way of saying it. Instead of saying NP complete, I could have said even NP. But then in the exam they might ask, they might give anything. I think the logic should be clear for you. See, what I mean to say is either it is NP problem or NP complete, both are present in this NP, right? And now I have found out a problem which is not in P but in NP. That is what my meaning is, right? If you are able to find out at least one such problem, then and if you are able to prove that there is existence of one such problem, then P is not equal to NP. But no one is ever able to do both of them. So as of now, what about NP? We don't know. What about NP complete? We don't know. We just know that NP complete problems are as hard as any problem in NP. That is what we know. It doesn't mean that NP complete problem is exponential time or NP hard problem is exponential time, right? As of now, status of NP is unknown. Maybe you could take that point as well. Status of NP is unknown. No one knows what that what are the problems. I mean, can we solve it or no? No one knows about it. Only about P we are very sure that we can solve them in polynomial time. About NP we can know that they can be verified, but we don't know anything about the solution. I mean, we don't know whether it could be solved in polynomial time or not. In future, if someone comes with a solution, many things change. Or in future, if someone gives this proof that it cannot be solved, many things will change, right? So now what can we say about the problems? See, definitely these problems are not as of now we are not able to solve these problems in polynomial time. It doesn't mean that we are not supposed to solve them at all, right? We have in a real life, we have many problems which are in NP which are not yet solved in polynomial time. Then what we should do in such cases is we should take up a close approximation. They are called heuristics. Okay, I'll talk about it, and before going ahead, let me take some few points about it. See, now assume that a problem is NP hard. NP hard means there is some problem to which already all these problems are converted, right? I don't care whether this problem is inside or outside, right? And now say this problem A, let us say this is problem A, which is NP hard. This is problem A, which is NP hard. Now if you are able to convert this problem to other problem B in polynomial time, then what can you say? Every problem can be converted to this problem in polynomial time, and then this problem can be converted to this problem in polynomial time, and therefore every problem can be converted to B in polynomial time. Therefore, if you are able to convert any NP hard problem to some other problem in polynomial time, then this problem would in effect become the NP hard problem, isn't it? Why? Because you are able to convert everything to A. It is like this: in a classroom, someone is able to beat everyone in arm racing, and now there is a new guy who came up and he is able to beat him in arm racing. Then he is as hard as everyone in this, right? So which means if you are able to solve every problem in NP, convert every problem in NP in polynomial to some problem, and from there to some problem, then this problem will become, B will become NP hard. Got it? And if it is already given that B is a problem in NP, now it is NP as well as NP hard, therefore it will be NP complete. So these proofs are used to find out some problems. See, why do you try to prove NP complete problem is because we wanted to do some research on them, because we wanted to know that if solving that problem would lead you to some solution. There is no other significance than that. We just try to get some problems in NP complete and then we work on them, so that if anyone can solve it, it means that they are solving everything. We are actually interested in finding out the leaders, the toughest problems in the class. Got it? So one proof here is, so maybe you could write this point now. If A is NP hard, which means A has beaten down everyone. A is as hard as any problem in NP, and A is converted to B in polynomial time, then what can you say about B? Then B becomes as hard as any problem in NP, because from every problem to A there is a conversion, and A to B there is a polynomial time conversion. Therefore from every problem to B we are now able to find out the polynomial time conversions. Therefore what can you say? We can only say that then B is NP hard, but we cannot say that B is NP complete. Now when can you say that B is NP complete? If this statement is true, as well as, and if B is already known to be let me write it here, let me write it completely, so you can take that point. Now see, why am I saying all these points is, maybe if you missed out when I am speaking, at least you write down when I am writing it down. Okay, these points are very important, and I am expecting that there will be at least 1 or 2 questions in the GATE next year, because the GATE pattern has changed so much that they are focusing really on these areas: P, NP, NP hard, NP complete. Okay, now if A is NP hard and B is NP, which means there is already a polynomial time verification algorithm for B, and A could be converted to B in polynomial time. Then what can you say about B? Definitely B is NP hard, and it is already given that B is NP. Therefore B is both NP and NP hard. Therefore what can you say? Then B is NP complete. Got it? So now we'll take already known one NP hard problem or one NP complete problem, and then we shall try to convert it to some NP problem, making that a NP complete. So once we get the set of all NP complete problems, we would actually work on them and then find out whether P equal to NP or not. But then proving that a problem is NP complete does not mean that it is a proof to say that it is a exponential time algorithm. It does not mean that. Okay, keep that in mind. It is a common misconception saying that if you can prove that a problem is NP complete, you can prove that it is exponential time. No, you could only say that no one is able to prove such a problem in polynomial time. Therefore the chances are that I might not be able to prove that, right? I may not be able to solve it in polynomial time. Only that thing you could say. Other than that you cannot say anything. As of now we don't know anything about NP. Got it? Okay.